All right, next one. Now I look at this and I can see right away that there's been a shift up, right? It's not on the x-axis. So let's start with that midline. Here's your max y. Here's your min y. So it's going to be 3 plus 1 over 2. Now, given that I can calculate a k equals 2, some of you can probably look at it and say, oh, that's the middle of the graph right there. I can see that the maximums and minimums are the same distance away from that line. That is perfectly okay. You do not have to use the formula to calculate k. Okay, let's see, is it sine or cosine? Well, here's the midline, and here's the x-axis. It is not on the midline, it's above the midline, which means it's a cosine graph. Okay, let's do the amplitude. 3 minus 1 this time. Looks like the amplitude is 1. Now we're going to say, is it reflected? No. Again, it's the same. It's still got a max. So my A equals 1. Okay, let's go with period. So 1 cycle. Whoops. That's not pretty. It's going to erase my midline, but that's okay. Oh, it did it good. Yay. Okay, 1 cycle looks like this. Stops back up here at the maximum, and it looks like it's at pi again. So our period equals pi. We've got to solve our equation for b. 2 pi over p again. Looks like it's exactly the same. Okay, b equals 2. That means our equation is going to be y equals a, which is 1. We can leave it off, times the cosine of b, x. Now we do have a k, so we've got to add that vertical shift, that k, onto the end of it. So just to make sure, a was 1, b was 2, and k was 2, just so you remember where each piece went. Okay, so this next one says a rodeo performer spins a lasso in a circle perpendicular to the ground, so kind of pretend like this is more like one of those. The height of the knot from the ground is modeled by blah, blah, blah. Typo. Oopsie. That's a T. The height of the knot, so this little place where they kind of hold on to it, or where the handle meets the actual loop. I don't know what that's called. Knot, but anyways. The height of the knot from the ground is modeled by this trig function right here, cosine, where t is measured in seconds. So the height of it, we'll call it h of t, looks like this. Now, regardless of the fact that it's a model, given this equation, we can identify our key pieces, right? We need to know an amplitude. We need to know that it's reflected. This is B, and this is D, any kind of midline shift. Okay, first question says, what is the highest point reached by the knot? Well, highest point for a trig graph means a maximum. So let's picture what's going on here. When you would go to graph it, it's cosine, so we're going to start on our x-axis out here. We'd have our 4 points out. We would have our, so many's up, so many's down. And then we would put our point. Usually it starts at the maximum, but it's been reflected, so it's actually going to start down here at the minimum. Now my amplitude was 3, so I went down 1, 2, 3. Change colors. So I'm reflecting it down 1, 2, 3. So that's actually going to go there, which means the final one out here at the end is there. The minimum happens in between. And then we've got our 2 asymptotes right there. Intercepts. Sorry, I was close. That would be a basic cosine function, right? Now the labels would be based on the period, but to find the maximum and the minimum, we don't need to know what the period is. All we need to know is the amplitude and if it has had a midline shift. It does. It said, hey, go up 3.5. So this point right here, right now, is at -3, 0. If I move that up 3.5, I would end up here at about 0.5. Right? Just added those two together. Now, same thing, there's a point up here. It's just at the end of the period. This one right here, though, it is at the middle, right? And its y value is +3. So if I increase that and move it up 3.5, that maximum right there is now going to be at 6.5. So what is the highest point reached by the knot? That would be this 6.5. 6.5, let's say feet. We'll pretend it's feet. It's awfully big, but whatever. Then it says, what's the lowest point? Well, the lowest point means minimum, which is that other point we found. This guy right here. So 0.5 feet. I mean, it could reach that high, I guess. Then it wants to know the period. Now, period would be how long it takes to make one loop, right? If we're talking about in seconds, then as always, to find our period, we would take B and do 2 pi divided by B. Okay, over 1, change it to multiplication. Pi's cancel. On top is 2 times 3 is 6 over 5. So 6/5 seconds. That doesn't make sense. So this would be one of those times that we would say, oh, what is that as a decimal? 1.2 seconds. So that right there is how long it takes to go from its minimum height, 0.5, up to its maximum height, or vice versa, or halfway there to down, one full circle, I guess.